All right, this is the study guide for Algebra 2, Unit 9, Counting Principles. All right, so to start this off, the first 3 problems, they want you to give them the formulas for these. These are clearly stated in your lesson. Permutation for NR, combination for NR, and a circular permutation. That's what that little C right there means. A circular permutation, all right? So a regular permutation, actually I want you to find these on your own. They're very clearly stated and I'd rather you find them. All right, starting at number 5, they ask you to, some true and false and questions about number 5 and 6, I'm sorry. What kind of sequence it is. So in this one they give you, on number 5, they give you 4, -4, 4, -4 is an example of an infinite alternating sequence. So as soon as there's ... you know it's infinite. And then alternating is any sequence that says positive, negative, which this one does. So yes, that is an example of a infinite alternating sequence. And then problem number 6 says 3, 9, 81, 243. Is an example of an infinite arithmetic, is not an example of an infinite arithmetic sequence. All right, so arithmetic says the same number is added every time. And you can tell by how exponentially this one changes. 3, 9, 81, 243, you're not adding the same thing every time. So no, this is not arithmetic sequence. So true, because it says it is not an example. So true, it is not. Numbers 7 through 11. Those are the ones we're going to talk about. So number 7 says, type the general term for the following sequence: 2, 4, 8, 16, 32, right? So this isn't multiplying by 2 every time, because 2 times 1 is 2, 2 times 2, right, because n always starts at 1, right? So that would say 2 times 1 is 2, 2 times 2 is 4, 2 times 3 should be 6. So that's not what's happening here. But I know that 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. So I think that's what's happening here. So 2 is here, and then it's to the power of n. N is starting at 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. All right, so that's the general term for this sequence. The next sequence says 3, 6, 9, 12, 15. 15 over 4, 5, 6, 7, 8. So remember, n always starts is 1, and then it goes up. So for the bottom, it's not just n. If it was just n, it would start at 1. So we have to say this is going to be 1. To get 4, it's going to be 1 plus 3, right? To get 4, and then 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. 5 plus 3 is 8. So the bottom is an arithmetic sequence of n plus 3. We're adding 3 every time. On top, though, it's 3, 6, 9, 12, 15. Those are the factors of 3. So I think we're multiplying by 3 every time. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So that means 3 times n every time. Then in problems number 9, 10, 11, they're going to ask you to identify whether it's an arithmetic, a geometric, neither, or both. So the first one says 6a plus 6a squared plus 6a cubed plus 6a to the 4th, and so on. And they give you the general term is 6a to the power of n. So that is geometric. As soon as you have an exponent, it's a geometric sequence. Number 10 is a summation. So when you see this sign here like this, I'm not very good at writing them. That is called a summation, which is arithmetic. Okay, a sums is, okay, so as soon as you see that, oh, that's a summation. And then we have an alternating sequence in number 11, -7, +7, -7. That's a geometric sequence because you have to multiply by -1 to do that. So as soon as you have that alternating, you got to know it's negative. I think the answer key says neither, but it's not true. It is a geometric sequence. All right, then starting at problem number 12, we're going to do some permutations. So this one says permutation 5, 5. All right, so at the beginning of the study guide, you did the permutation formula for NR, but that's not what this is. This is NN. When there's two that are exactly the same, the formula for that is just n factorial. Okay, so you don't have to do a bunch of stuff here. You just have to go 5 factorial. We all know we can do that on our calculator with the factorial button. But what this means is that you've got to go 5 times 4 times 3 times 2 times 1, which isn't that hard. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So that one's done. Problem number 13. I know I'm struggling today. You have to forgive me. Problem number 13. Oh, Lord. Problem number 13 is a combination with n. Now, this one, you do have to do the full formula to solve it. They don't tell you that. They don't tell you that the formula is n factorial because it doesn't work. But when you do this equation, which they tell you 6, 6, every time you do this, the same thing's going to happen. You're going to go 6 factorial over, and the formula for this is n factorial over r times n minus r. So 6 minus 6 is 0. Factorial, which is 1. 0 factorial is always 1. So then when this is 1 and those just cancel, it's always 1. Whenever you have a combination with the same number, it's always 1. That's the answer. All right. Problem number 14, pretty straightforward. They asked for 6 factorial. That means you need to go 6 times 5 times 4 times 3 times 2 times 1. Number 15, they do ask you to do the combination of 6, 2. So remember your formula for a combination is n factorial over r times n minus r factorial. All right, so n in this case is 6. 6 factorial over r, which is 2 factorial, times 6 minus 2, which is 4 factorial. So the easiest way to do these is to march this top down till it matches with your highest number in the denominator. So you would go 6 times 5 times 4 factorial, and we have a 4 factorial down here that we will cancel it with. So we have 6 times 5, which is 30, over 2 times 1, which is 2. So 30 divided by 2 is 15. That'll be your answer. Problem number 16, they ask for a circular permutation, okay? So it has a P and it has a little C next to it of 4, 4, right? So in this case, for a circular permutation, this is not the same one as it's on the front page of your study guide because that is NR. Again, this one is NN, so it has the matching numbers right there. The formula for this is n minus 1 factorial. So in this case, it's 4, 4. So you're going to go 4 minus 1 factorial, which will give you 3 factorial, which is 3 times 2 is 6 times 1 is 6. So 6. Number 17, they give you a little equation here, they say 3 factorial plus 0 factorial over 2 factorial times 1 factorial. Now, 3 factorial would be 3 times 2 times 1, which is 6. 0 factorial is always equal to 1. So plus 1 over 2 factorial is 2 times 1 is 2 times, so pay attention, that's a multiplication. 1 factorial is 1, so 2. So 6 plus 1 is 7 over 2. The end. Number 18, they're going to start giving you some problems to work out with permutations and combinations. They say a person is wearing a bracelet with 10 settings around the bracelet. How many different ways can 10 birthstones be arranged around the bracelet? So remember, we just covered this. This is a circular permutation with 10 settings and 10 stones. So circular permutations with n or the same number is just that number minus 1 factorial. And that's actually what they want. They don't want you to work it out. They want you to put 9 factorial as your answer there, okay? So don't actually work out the problem. Number 19, they say how many subsets of 3 elements exist in a set with 5 elements, all right? So subsets is always a combination, okay? It's not a permutation. Subsets are always combinations. So they say you have a combination, 5 elements, and you're saying how many subsets can I make of 3 elements? So remember your combination formula is n, which is 5 factorial, over r, which is 3 factorial, times n minus r, which is going to be 2 factorial. And the easiest way to work these out is to say 5 times 4 times 3 factorial, and the 3 will cancel there, and then we have 2 times 1 on bottom, which is just 2. So it's 20. 5 times 4 is 20, divided by 2 is 10. Number 20, how many different groups of 48 cars can be formed from 50 cars? So anytime they say groups, it's also combination. The only time it's going to be a permutation is when it cares about the order. The difference between combination and permutation is that permutation cares about order, and combination is just about making groups. All right, so they say this is a combination. They have 50 cars, and they want to make groups of 48. How many different groups of 48 can I make? So we're going to say 50 factorial, remember, again, the combination formula, over 48 factorial times 2, because 50 minus 48 is 2. Again, we're going to march this down. 50 times 49 times 48 factorial over 48 factorial times 2. Again, the 2 times 1 is just 2. So to get your answer, you go 50 times 49 and then divide it by 2. Number 21, how many different ways can an executive committee of 6 people sit at a round table? So again, another circular permutation with, they don't tell you there's 6 seats, but they don't tell you there's more. So it's just 6, 6. So remember, in a circular permutation with n, the same number of seats and people, the formula is n minus 1 factorial. So 6 people, so 6 minus 1 is 5 factorial, and you'll get your answer. And then the last 2 problems are probability problems. So remember, in probability problems, you put the outcomes favorable, or the ones that they ask you to, on top, and on bottom is all the options. So in the first problem, they say, what is the probability of not drawing a green marble from a jar containing 4 red, 5 green, 2 white, and 8 blue marbles? So on bottom, we need to put how many there are altogether. Well, there's 4 and 5, which is 9, plus 2, which is 11, plus 8, which is 19. So there's 19 altogether. And then what are the conditions we want? We want anything that's not green. So how many are not green? 4 red, 2 white, that's 6, and 8 blue. So 6 and 8 is 14 out of 19 are going to be not green. All right? And the last one, a compound experiment. Okay, so compound means you take your 2 probabilities, or 3, or whatever, how many ever they give you, and you multiply them. A compound experiment consists of drawing at random twice without replacing from a jar. Okay, so we're not going to replace. with 3 red, 3 white, and 2 black marbles. What is the probability of first a red getting a red and then a black? All right, so number 1, we need to know how many are in there altogether. We have 3 red, 3 white, which is 6, and 2 black, which is 8 altogether. And we want to first get a red, and there are 3 reds in there. So good chances. Less than 50% chance. And without replacing, so that means we're not going to put it back. Now there's only 7 marbles in there. And this time we want to get a black. And there's only 2 black marbles in there. All right, so compound probability, we're going to multiply these. We could reduce before we multiply. It would actually, you can reduce before or after, but 2 and 8 reduce to 1 over 4. 3 times 1 is 3, and 4 times 7 is 28. And that's your final answer. You have a 3 out of 28 chance of getting those right marbles. This is a pretty simple test, but still be careful and make sure you're doing things correctly.